Hi everyone. The paper I'm going to talk about is Targeted Online Password Guessing, an Underestimate Threat. This is the presentation for class CS6263. These are the authors of this paper. They are Ding Wang, Zijian Zhang, Ping Wang, Jeff Yan, Xinyi Huang, and below are the school they come from. The paper was first published in the Proceeding of CCS on 2016, and we could find this paper through the link below. Here are some background of the paper. Password remain the most popular user authentication method in various computer systems. There are some successful developed algorithms that try to understand the password security. For example, Markov Ngram, PCFG. I emphasize these two here because the new algorithm in this paper is developed based on these models. And if you're interested in the detail of them, you could find them from the journal below. But the detail of the algorithm is not mentioned in this paper. Back to the background introduction. A common feature of this guessing model is that they characterize a trolling offline guessing attacker who mainly work against the leaked password file and aim to crack as many accounts as possible. But no matter trolling ones or targeted ones, they only pose a real concern in a very limited circumstances. Like the server password file is leaked, the leakage goes undetected, and the passwords are properly hashed and sorted. A recently research has realized that it is the website's responsibility to protect users' password from offline guessing, and the user is to choose the password to survive the online guessing. Online guessing means anyone could launch an attack against the public-facing server by using a browser at any time, with limited guessing number of server. Trolling online guessing mainly exploits users' behavior of choosing popular passwords, and it can be well addressed by various security mechanisms at the server. For example, suspicious login detection. However, targeted online guessing uses personal identifiable information and leak the password to carry out the attack. And it can exploit not only weak popular passwords, but also passwords reused across sites and passwords containing personal information. As a result, it becomes serious security concerns. For example, 253 million American netizens become victims of PII and password leakage. Existing password creation rules and strength meter are based on the old trolling guessing model. We need to develop a new model to address these security problems. The picture on the left is the process of targeted online guessing attack, starting from learning users' behaviors and personal information to eventually hack into users' account. This paper is trying to build a model or an algorithm that could carry out the targeted online guessing. Here are some of the challenges to build the model. First, the password choice are very different. And the second, the user's personal identifiable information is highly heterogeneous. A diversified set of transformation rules to modify password for crossing-site reuse. The diversified transformation rule include insert, deletion, substring, or reverse. And the last challenger is the transformation rules for password reuse are often context dependent. For example, the password contains Yahoo. It's more likely to be used on the Yahoo website. In this paper, the authors present a framework to characterize typical targeted online guess. They name it TARGUESS. TARGUESS captures 7 typical scenarios, which each based on a different combination of various information available to the attacker. And they proposed the probabilistic algorithm from targets 1 to targets 4 to cover the different scenarios. As you can see in the picture, that targets consist of 3 phases: preparing phase, training phase, and guessing phase. We will start from the preparing phase and see how the authors start with their initial data and how they handle the data so they could use it in the training phase. Since we already see the framework of the model, let's see how the paper collects the preliminary data for the training. The first data is the personal information, and this is the most prominent feature of the targeted online guessing attack. The personal info is a wider concept. It contains 3 categories. The first is the personal identifiable information, PII, which is semi-public. Second is the user identification credentials, which could be either public or private. The third are all the leftover personal data which do not use in this study. For the first category of PII, they further divide into 2 types. Type 1 include names, birthdays, phone number. Type 2 include gender, age, and language. The second part of the preliminary data is the security model. The paper assumes there are 3 entities in an attack. First, an attacker will try different strategies to crack the password. Second, a server that enforces some kind of security method like suspicious login detection. Third, a user whose personal information has leaked. From some previous publication, the paper also assumed that most users have leaked one sister password, and the attacker can exploit the user's sister password. The paper further analyzed the attacking situation and divided them into 7 scenarios. The paper lists the most common 4 scenarios based on different information they contain, and the scenario 5 to 9 are less common. Different target algorithms have developed based on different scenarios. The third part of the preliminary data is the study of human behaviors of password creation. The author analyzed 10 large real-world password datasets, and 2 of them even include personal information, which you can see the details in Table 3. Since some of the password lists have no PII, the paper correlates them with the PII dataset of the same language by matching emails. Then they further rebuild into 7 data lists for training phase. The blue part highlighted in Table 6 are the 7 rebuilt data lists, and the number right below is the size of the list. Here are some of the findings of the behavior study. That the first one is the most disturbing one. 0.79 to 10.44% of the password can be guessed by just using the top 10 passwords. And as expected, user likes to use username, birthday, and their variations in the password. When we get down to the Table 6, the yellow highlight means that 4.68% of the PII-associated Dudu News users use their full name to build passwords, and 0.82% of these user passwords are just their full names. I only include part of the full list in this slide. If you're interested, you could go check into the paper. Before we enter into the model training session, there is one more concept I have to mention for better understanding of this paper. The paper used tag method to recognize the PII versus the traditional length-based method. For example, name is giving a tag of N, birthday is giving a tag of B, and then they further use subscript number to further divide these tags into subtypes. For example, N1 means the usage of family name. Here is the targets framework again. We are entering the training phase now. This table comes from preliminary data session. The paper developed 4 targets models to deal with 4 most common scenarios. Targets 1 has only type 1 PII, Targets 2 has only one sister password, and Target 3 has type 1 PII and one sister password. Targets 4 has type 1 PII and type 2 and sister password. Here is the details of Targets 1. It mainly just about tags for different training dataset. The content here is using PII tag impulse with PCFG algorithm, which I emphasized in the background introduction. And if you remember that we just talked about the PII tags with subtags, here is where they use. For example, in set V starting from L, which stands for letters, D stands for digit, and S stands for symbol. N1 denotes the usage of family name, N7 for family names with its first letter capitalized, B10 for date in DM format, and the last 2 digits of the year. A stands for account name use. A1 is for account name, E is for email prefix usage, and P is for mobile number usage. For better understanding, we could see the image on the right. Here are some of the results of Targets 1. With 100 guesses, Targets 1 has a success rate of about 20%. With 100 to 1,000 guesses, Targets 1 has a better performance than personal PCFG by cracking more passwords. Also, Targets 1 is highly adaptive. It could employ with other algorithms like Markov by adding new tags. For example, hobby. The next model is Targets 2, which is developed based on only knowing one sister password. The challenges are the limit of online guessing number, and there are a lot of different transformation rules. For example, insertion, capitalization, how to get the top candidate of the guessing password. The paper tried to use a data-driven approach to solve this problem. This is the way they select password pairs. First, matching user by email in 2 different password lists. Second, eliminate identical password to create a new list of non-identical sister password pair. Third, measure how password B is modified from password A, or whether password B is simply a popular password. The paper selects the top 10,000 passwords from various leaked password lists to build the top popular password list. Then, if this password B is not in the list, the password pair will go through structure level training, then segment level training. For the structure level training, it first pass the password in letter, digit, or symbol tags as in Targets 1. Then 6 main types of transformation will be considered: insert, deletion, capitalization, substring movement, reverse, and lit. After finish the structure level training, it goes into segment level training with only 2 rules, insert and deletion. Together, there are a total 8 rules and some numbers of their subtypes. For example, TI means tail insert, and HI means head insert. Eventually, we come to Targets 2, context-free grammar, which is similar to Targets 1. The example on the right gives a general idea of how to calculate the probability of a given password. It then further considers a factor alpha, which represents a fraction of users who do not choose the top password. Finally, these 2 probability-associated lists are merged and sorted in decreasing order. and then the authors select the top K as the final guess candidates. Here is the result of TarGuess 2. When giving a user one sister password, within 100 guesses, TarGuess 2 can gain a successful rate of 20.19% against the user's other service account. And then TarGuess 2 outperformed the similar algorithm by up to 300%. And if you're interested in the similar algorithm, you could check the paper below. The next model is TarGuess 3, which has type 1 PII and 1 sister password. More information means more things need to be considered. The paper solved this by introducing PII tags into the grammar of TarGuess 2. In the training phase, all the PII-based password segments only involves the 6 structure level transformation rule as defined in TarGuess 2, and all the other things remain the same. And we can see the result of TarGuess 3. It can achieve a success rate of about 23% when allowed to try only 100 guesses. Here is TarGuess 4, which has type 1, type 2, PII, and 1 sister password. The major challenge here is type 2 PII, like gender, age, language, cannot be directly measured using the tag-based method. As the author mentioned before, giving a limited number of guesses, more information available generally means more things to be considered. In the TarGuess 4, since there are a lot of information offered, they provide a theorem to efficiently calculate the potential password candidate. If you're interested in the proof process, you could go to the paper section 4.4. I will only include the final equation 1 of the theorem in this presentation. From here, we could see that each part of the probability could be calculated. Here is the result of TarGuess 4. It can achieve improvements over TarGuess 3 by 4.38% to 18.19% within 10 to 1,000 guesses, and it can reach a success rate of about 24% within 100 guesses and about 30% within 1,000 guesses. If you remember that other than the most 4 common scenarios, there are still other less common scenarios. As you can see, scenario 5 and 6 could be solved by the variations of equation 1 from TarGuess 4. Scenario 7 could be solved by first using TarGuess 2 to generate a list of guesses and then adjusting the probabilities of guesses according to equation 1. As for scenario 8 and 9, they are still unsolved. Now, let's get into the evaluation part. The paper compared 9 algorithms with rebuilt password list. And they correlate password list with the PII datasets of the same language by matching email. It is the same method as I mentioned in the preliminary data session. And here is the result of the evaluation. TarGuess 1 outperforms its foremost counterpart, Personal PCFG, by 11.17% to 509%, and the average performance is 84%. TarGuess 2 outperforms the DAS algorithm by 8.12% to 300%. The average is about 111% when cracking non-identical password pairs. And TarGuess 3 and 4 can gain a successful rate of about 73% when attacking Chinese normal user and of 31% when attacking English security savvy users. I only include part of the figures here. And if you're interested, you can go check in the paper. To further evaluate their models, the author launched a rail attack to Xiaomi Clouds. And Xiaomi Clouds are MD5 hashed with salt, and it was leaked from the world's third largest phone maker. So I Googled that in 2016, the third largest phone maker should be Huawei, but I couldn't 100% confirm this information. The result is prominent, that target 3 and 4 can gain a success rate go up to about 73% within 10 to 1,000 guesses. Here are some more results of the evaluation. These results suggest that the majority of the normal users' passwords are prone to be a small number of targeted online guesses. As normal user passwords are even not strong enough to resist the online guessing and still far away from the online-offline password chasm. In all, targeted online guessing is a much more damaged threat to password security than trolling guessing. This is the final conclusion of the paper. First, an online guessing attacker can gain advantages by exploiting various types of users' personal information, including leaked passwords and common PII. Second, they build 4 successful models of targets 1 to 4. Third, their results suggest that the currently used security mechanisms would be largely ineffective against the targeted online guessing threat, and this threat has already become much more damaged than expected. This is the end. Thank you for watching.